My name is Soumya. I am a graduate in MTech Polymer Science and Technology. I am here to teach you about polymer science. This course will be helpful for those who are studying in MTech, BTech, MSc, BSc in polymer science, and also for those who are preparing for job interviews and competitive exams based on polymer. In this video, I am going to talk about the basics of the polymer, that is, introduction, uses of polymers, what are polymers, how are polymers formed, classification of polymers, chemistry of polymers. Did you ever hear about polymers? If there is any, I can tell you that nowadays polymer is an inevitable material due to its outstanding performance and properties like lightweight, less expensive, flexibility, durability, electrical properties, mechanical properties, optical and thermal properties. So, its uses are increasing day by day. Some applications are described here. So, in medical field, it is used for making sutures, disposable syringe, replacement of heart valves, replacement of bone, artificial skin, contact lenses, artificial heart. And example for these are nylon, polyvinyl chloride, it is written as PVC, polyethylene, polypropylene, and polymethyl methacrylate. While in construction field, it is used for making pipes and guttering, windows and doors, roofing, sealants and adhesives, flooring and building panel. Example for these are polyvinyl chloride, polystyrene, polymeric fibers. In automobile industries, it is used for making instrument panels, engine, tires, body panels. Example for it is are natural rubber, butyl rubber, styrene butadiene rubber and various plastics. In our daily life, we can see various products that we are using are made up of this polymer, such as mug, plates, chair, table, brush, which are made up of polymers. Example for this is are polyethylene, polypropylene, polystyrene, polymethyl methacrylate, nylon. And in aircraft, it is used to construct aircraft components such as body panel, vision window. Example for it is polyvinyl chloride, silicone, epoxy, fibers, nylon. In electrical field, it is used for making organic solar cells, organic light emitting diodes, rechargeable batteries, electromagnetic shielding in television, mobile phone, computer. Example for it is polypyrrole. This is a conducting polymer. I will discuss about conducting polymer in future videos. So, what are polymers? The word polymer is derived from a Greek word called poly, which means many, and mer, which means part. So, polymer is formed by combining many small parts and forms a longer part. It is a very large molecule. It is formed by combining two or more monomers. So, normally its molecular weight becomes very high. Let's see how polymer becomes high molecular weight compound. Consider a low molecular weight compound called water. Its molecular formula is H2O. Its molecular weight is 18. How? Atomic number of hydrogen is 1. So there are 2 hydrogen atoms, 1 into 2, plus atomic number of oxygen is 16. So it becomes 18. Similarly, another low molecular weight compound called ethylene. Its molecular formula is CH2 double bond CH2. So there are 2 carbon atoms. Atomic number of carbon is 12. 12 into 2 plus 4 hydrogen atoms. 1 into 4, that is equal to 28. Next, we can see how polyethylene occur from ethylene monomers. Literally, a polymer is formed by combining more than 100,000 monomers. Here, just to understand how molecular weight becomes high, I shown as 4 ethylene monomers combines to form polyethylene. So, one ethylene monomer has a molecular weight of 28. So, when 4 ethylene monomers combines, its molecular weight becomes 28 into 4, that is equal to 112. This is how the molecular weight of a polymer is increasing. That is, it depends upon how many monomers participates in it. So, if there is a polymer that is formed by combining more than 100,000 monomers, we can't write all the monomers completely here. So, it can be written as CH2 single bond CH2 suffix N. And the suffix N denotes the number of monomer units or number of monomers. So, ethylene plus ethylene gives polyethylene. This is how the polymer is forming. That is, many monomers combines to form a longer chain. That is polymer, and this process is known as polymerization. We will discuss about polymerization in detail in coming videos. Next, how polymers differ from low molecular weight compound. Consider a low molecular weight compound called benzene. When we apply heat on a benzene, first it turns into liquid, and on further heating, it will turn into gas. So this is a basic response of a low molecular weight compound upon heating. While in the case of polymer, when we apply heat on it, first it turns into a molten liquid, and on further heating, it turns into the formation of a decomposition product. For example, when we burn woods, it turns into a black substance called carbon. That is a decomposition product formed from it. This is a basic response of polymers on the application of heat. Next, we can discuss about the difference in solubility behavior of low molecular weight compound and a polymer. Consider a low molecular weight compound called salt. When we mix salt with water, first it goes into the solution. But when it reaches the saturation point, if we add more salt into it, it remains undissolved. The viscosity of the solution is same as that of the water. There will be no change in the viscosity. While in the case of polymer, consider a polymer polyvinyl alcohol. When we add polyvinyl alcohol into water, first it starts swelling because polymer is a high molecular weight compound. So first the water molecules will enter into the polyvinyl alcohol and it starts swelling like this. And after that the PVA starts dissolving. It is a time consuming process because of the high molecular weight of the polymer. At last we get a viscous polymer solution. Here the viscosity is increasing due to the high molecular weight. And if we add more PVA molecules into it, we can dissolve it. This is the difference in solubility behavior of low molecular weight compound and polymer. Next, how are polymers formed? As we already discussed, many monomers combines to form a longer chain is called a polymer, and that process is known as polymerization, and these each one are known as the repeating units. Then what is degree of polymerization? Number of repeating units formed in a polymer is called degree of polymerization. For example, if 10 ethylene molecules combines to form polyethylene, so the number of molecules participate in it are 10. This number is known as the degree of polymerization. For example, here there are 9 monomers participate, so the degree of polymerization becomes 9. Here there are 10 monomers, so degree of polymerization is 10. Here 11, so the degree of polymerization is 11. Next is the classification of polymers. First one is natural and synthetic polymers. In nature, we can see so many natural polymers like cellulose, silk, protein, woods, and so on. Also, we get natural polymers from bioresources like bacteria, fungi, even in our body like skin, bone, hair. All these are natural polymers. Another interesting fact is that we can modify this natural polymer and forms a synthetic polymer. Also, we can synthesize polymer from low molecular weight compounds like ethylene, propylene, styrene, and so on. Examples for natural polymers are DNA, rubber, cellulose, wool. The example for synthetic polymers are nylon, polyester, Teflon, epoxy. Next, classification based on organic and inorganic. Polymers whose backbone is made up of carbon atoms is called organic polymers. For example, polyethylene, here the backbone is made up of carbon atoms. And polymer whose backbone other than carbon atom is called inorganic polymers. Example silicon, glass, oxygen. Here we can see the backbone is made up of oxygen and silicon. Next, classification based on thermoplastic and thermosetting. Thermoplastic polymer can be repeatedly softened on heating and hardened on cooling. It can be used again and again. It is expensive. It is recyclable. Example for it is polyethylene, polypropylene, polystyrene, and so on. While the thermosetting polymer is a permanent setting polymer, as it gets hardened and sets during molding process and cannot be softened again. It once it's set, it never can be reshaped. It is not recyclable. Example, bakelite, melamine formaldehyde, and so on. Next, we can start about the chemistry of polymerization. So, the polymerization is a process in which the low molecular weight compounds combines and results in the formation of polymer. In polymerization process, the molecules combine, same molecules or different molecules will combine to form polymer. So, what is actually happening in this process? Molecules must be able to react with each other, whether it is same or different. That is, it contains functionality. It must contains functionality. So, what is functionality? It is the presence of reactive sites in a compound like OH, COOH, NH2, hydroxyl group, carboxylic groups or amine groups and so on. But in some compounds, it doesn't contain any reactive sites. In such cases, reaction is done by the presence of double or triple bonds. For example, in the case of polyethylene, in the case of ethylene monomer, CH2 double bond CH2. So the reaction will act upon this double bond. So there are two main methods of polymerization. First is addition polymerization, second condensation polymerization. First we can discuss about addition polymerization. So in addition polymerization, polymers are formed by just adding monomer one by one and thus forms a longer chain like a train bogie. And after reaction, no byproducts will form. Normally, monomers containing double bonds will undergo addition polymerization. Example, ethylene, butadiene, vinyl chloride. We can see as in the case of ethylene monomer. Here, when the reaction happens, this double bond will break and forms a longer chain like this. So, here there is same elemental composition. No byproducts will forms. We can understand in detail. Consider monomers containing reactive sites like methanol, CH2OH plus acetic acid. So here in the methanol it contains hydroxyl groups and here the carboxyl groups are present in it. When it reacts together, we get ester, that is CH3, COO, CH3 plus H2O, that is this OH and this H will eliminate. These are the byproducts formed. This is the reactions happens in the monomers that containing reactive functional groups. But in the case of monomers containing double bond, no byproducts will form. Same elemental compositions are there. Normally, this monomers containing double bonds undergo this addition polymerization. So then there are three steps in addition polymerization: initiation, propagation, and termination. So these three steps are done by free radical, ionic or coordination mechanisms. So based on the mechanisms, it is again divided into three, that is free radical polymerization, ionic polymerization and coordination polymerization. First we can discuss about free radical polymerization. So let's see how the initiation will be done by free radical. This step is done by free radical formed by the homolytic decomposition of initiator. That is, when we apply thermal energy to the initiator, that thermal energy may be heat, light or high energy radiation. So when we apply thermal energy to the initiator, it will undergo homolytic decomposition and thereby forms free radical. This free radical will enable the polymer chain growth. That is initiation of the chain growth. Example for initiators are azo compounds, para-acids, peroxides and so on. So we can written it as R single bond R. So this is the pair of electrons forming the bond between two R's. So the pair of electrons forming a bond between two R can be written like this. So when we apply heat on it, it's split up into two equal parts, two identical fragments like this. So each part contains one lone electron, which is eagerly waiting to couple with another lone electron pair and thereby get stabilized. So that is a free radical. So example for it is our azo compounds, para-acids, peroxides. These are the examples of initiators. Let's see with an example of benzoyl peroxide. See, this is benzoyl peroxide. So when we apply heat on it, it split up into two identical fragments. So we can write like this. Forming the free radicals. So whenever we apply heat on an initiator, it splits up into two identical fragments with the free radicals. So it contains a lone electron which is eagerly waiting to couple with another lone electron and thereby get stabilized. So this free radical is very reactive. So whenever we add this initiator into the polymerization reaction, this initiator enables the chain growth of the polymer. So the rate of decomposition will depends upon a temperature, solvents and its chemical nature. So let's see how the initiation starts the chain growth. We know that a free radical is very reactive because it contains a lone electron which is always eagerly waiting for another lone electron to couple and then get stabilized. So let's see what happens when a free radical reacts with a monomer. So normally the double bond between two carbon atoms can be written as like this. So this double bond contains pair of electrons. So one pair of electrons between two carbon atoms in the case of double bond, one pair of electrons is exists as sigma electrons and which can be denoted as dash, and the other pair of electrons is exists as pi electron which can be denoted as two dots. So the double bond between two carbon atoms can be written like this. And this pi electrons, that is these two dots, which is always away from the nucleus, so it is easily attacked by the other reactive sites. So whenever a free radical reacts with a monomer, so the double bond is written like this. What happens is that one pi electron will shift to the this radical site, and then this radical gets coupled and then get stabilized, and the other pi electron will goes to the other end of the molecule. Okay, so thereby it forms R single bond CH2 single bond CH dot X. The radical site is formed at the first monomer unit. Thereby initiation starts. This is the process happening in the initiation step. Then after initiation, we next is a propagation. So the radical site formed at the first monomer unit will attack the radical site of the second monomer unit, thereby the chain growth will increase like this. R CH2 single bond CHX. This is this bond forming the radical site formed in the first monomer unit. Reacts with fresh monomer, second monomer. Gives R CH2 CHX single bond CH2 single bond CHX. So again another radical site is formed on the second monomer unit. Thereby in this way the chain growth will goes on further. The chain growth is increasing, and the process in which the attacking of the fresh monomer molecule one by one and thereby increases the chain growth is known as the propagation. And the addition of monomer can be of head to tail to tail, head to head, tail to head. So first we can see how the tail to head addition comes. Tail to head addition. This CH2 CH2 single bond CHX plus CH2 double bond CHX gives CH2 single bond CHX CH2 single bond CH dot S. So this is a tail of this monomer. This part is a tail and this part is a head. So tail to head. The addition is done by the tail to head form. Next we can see tail to tail. Again CH2 CHX dot X plus CHX double bond CH2 gives, that is tail to tail. Here the tail of this monomer is this, tail of the monomer is this, and so CH2 single bond, CHX, CHX, CH2. So, tail to tail addition. Next, we can see how the head to head addition comes. CHX, CH2 dot plus CH2 double bond, CHX gives CHX, CH2, CH2, CH. So, this is a head to head addition. Next, head to tail. It is CHX, CH2 plus CHX double bond CH2 gives CHX, CH2, CHX, CH2 dot. This is head to tail. These are the different method of addition in propagation. So next we can discuss about termination steps. After propagation, next step is termination. In propagation, the polymer chain growth is increasing. So further adding of monomer units to the growing chain should stop, and thereby growth of polymer chain is arrested. So the arresting or inhibition of the polymer chain growth is called termination. So let's see how this happens. Whenever a decomposition of a free radical occurs, there would be a formation of many free radicals at the same time. So each free radical can initiate and propagate the chain growth simultaneously. So several growing chains may occur. So when it depends upon the temperature, time, monomer concentration or initiator concentration, there will be a chance to collide two growing chains together, resulting in the arrest of chain growth. Based on this, there are two types of termination: termination by coupling and termination by disproportionation. First, we can see how termination by coupling occurs. That is, when two growing chains couples each other, what happens is that each growing chain contains lone electron. So, these two lone electrons will couple each other, thereby chain growth will occur. Chain growth arrest will occur. This termination is called termination by coupling. We can see that is R CH2 . This is the first growing chain with free radical site formation, that is this, plus next growing chain, second growing chain with radical site. So in termination by coupling, let's see what happens. That is R CH2 CHX CHX That is, here we can see this is the first growing chain with a radical site. This is the second growing chain with radical site. What happens when it collide together? That is, these two growing chains contains radical sites. So when it reacts together, this lone electron pair and this lone electron pair will couples each other and get stabilized like this. So the chain growth will arrest. This is the termination by coupling. This is termination by coupling. Next, about the termination by disproportionation. Here what happens is that hydrogen from one growing chain is abstracted by the other growing chain, thereby it stabilized by the formation of double bond. Here these are the two growing chains, and this growing chain will abstract one of the hydrogen atom from here, and thereby it forms CH2 here. This is in the first time it was CH, it was a radical site. So by abstracting hydrogen from here, it becomes CH2X, and there at last it forms a double bond here. Thereby it get stabilized and arrest the growth of polymer chain. This is the termination by disproportionation. So next we can discuss about chain transfer reaction. There is also another method of chain termination, that is by adding chain transfer agent into the growing chain, and thereby chain growth stops. In coupling and disproportionation, the products formed are dead or inactive, so further propagation is not possible there. But in case of chain transfer, the growth of polymer chain is arrested by the formation of dead polymer. Simultaneously, there will be the formation of new free radical which is capable of initiating new polymer chain. Let's see how it happens. This is a growing chain with a radical site, plus this is a chain transfer agent. That is, this growing chain will abstract hydrogen from the chain transfer agent. This hydrogen from the chain transfer agent, and it gets stabilized like this. This radical site will abstract the hydrogen from the chain transfer agent, and it gets stabilized, thereby arrest the chain growth. And simultaneously, there will be the formation of a free radicals which is capable for initiating new polymer chain. So in this reaction there is a transfer mechanism is happening. That is why it is said to be chain transfer reaction. So this is all about free radical polymerization. So we can conclude this lecture here. In this video, I had talked about all the basics of the polymer and little bit about the chemistry of polymerization. In the next video, I will teach you about ionic polymerization, coordination polymerization, and about the condensation polymerization. Okay, thank you.